I'm Suzanne Kresta, Dean of Engineering at the University of Saskatchewan, and welcome to my kitchen today. We're having a little bit of a COVID explore of mixing. I want to just introduce things by saying that engineering covers a much wider spectrum of things than we sometimes think about. Your cell phone, of course, is full of cool engineering components. When we think about precision manufacturing, we often think about cars and airplane engines, but it also shows up in quilt squares and embroidery. What we're going to focus on today is how chemical engineering and chemistry play out in your kitchen. So let's have a little bit of an explore in our kitchen today. I microwaved some milk, which changes how things work. So I'm just going to grab the milk. I'm going to foam up the surface with this little mixer. Later on we're going to talk about what different mixers do and why. This one's designed to make tiny air bubbles inside the milk. So I'm going to mix it for quite a while so we get a nice layer on top, and that'll help us to produce the next step in our process. Making coffee is really interesting because when you do it with boiling water, you get a very different flavor than if you did it with ice water. That's why you have to make the coffee first and then ice it. The solubility of what we call the aromatics in the coffee beans is a lot higher when you start with hot milk and hot water. So there we go, we've got a nice thick layer of foam on our coffee. I've got my coffee grounds that are ground up really fine because I want to get as much surface area as I can. That makes the solubility go faster. And I'm just going to wet those grounds because they resist wetting. There's some surface chemistry goes on, and I'll let them rest for a second. You can see a stratified layer forming here where the coffee is darker than the milk, and it's just going nice and slow so that stratified layer is staying separate, because I'm going to show you how easy it is to mix a little bit later. All right, those grounds are nice and wet and relaxed now, so I'm going to pour the rest of the water in. So you see you've got a foam layer, an espresso layer, and a milk layer forming here. And that foam is stable enough that it's coming off the top of the glass, and it's keeping its structure really nicely today. As your milk gets older, it doesn't keep its structure as well, so you see that break apart partway through the work. This and this, very different colors. I'm not even going to turn the motor on here. I'm just going to put this in and I'm going to touch it really gently because this is what we call ideal mixing. So I'll show you how easy it is. There you go. The perfect latte. Now, when we have water-like fluids that are completely miscible, and you can look the definition of that up in your chemistry book, that's the kind of behavior we get. But when we make salad dressing, we get a very, very different kind of behavior. So we're going to look at that one next. I want you to be able to see the structures formed. So once again, we're going to see separated layers of fluid when we put this together. There's some corn oil, some balsamic vinegar, Now, if I go in here and I just mix it gently, not much happens. That's an immiscible fluid. I'm getting a few drops, but I'm not getting any stable mixing. If I come back out, that'll all coalesce. So you can do this to your heart's content in your own life. Okay. Now I'm going to go in here and turn this on. And now instead of making foam, I'm dispersing really fine drops. And if we come in close, you'll see little sparkling happening. The sparkling is what happens when the drops coalesce and then they get bigger. And when they change the diameter of the drop, it changes the way the light reflects off the edge of the drop. So you get this sparkling as they come together. And it's really fine scale, so it's better to do that one at home. But if you look in here, you can't see any big brown drops anymore. You put it up the sides of the glass, you get a sense for how small those drops are. So let's just set that to the side and talk a little bit about the different mixers we use. So this one has a wire that goes around in a circle. And so the size of the wire tells us how big the drops or the bubbles are going to be. So they're really fine and it moves really fast. If you look at a submersible blender, there's a couple of really interesting things here. There's actually a blade that cuts through the drops or the ice cubes or whatever it is that you're trying to disperse. And then there's this funny shape around the sides. So one of the things that happens when you mix things is if you don't have that to break the vortex, your fluid can climb up the edges and go right off out of the glass. So I picked this glass because it has a nice high edge, but it doesn't take too much work to make your glass go all over the counter. And so this second version of this mixer has what we call baffles or vortex breakers around the sides. So this one is high-speed dispersing. Then there's some other things that we use in the kitchen. So this one is just large-scale mixing. All right. The fork, which has been a mixer for a very long time. Look at that same thing. Narrow edges with little holes between them so we can go really fast and make small drops. These two are interesting and fun because this one is a big scale and a smaller scale. But when we scale up, we actually get impellers that are taller in diameter than I am tall. So those are put into 20-meter diameter reactors sometimes, and treatment systems for drinking water, and mineral processing for extracting metals that go into batteries, and a whole variety of other things, including pharmaceuticals, fine chemicals production. So it's a really fascinating field. But one of the things that is the engineer's job is to figure out on a small scale like this, what do we need to do to accomplish our goal of dispersing that salad dressing so that we can specify how big the impeller needs to be and how fast it has to turn when we scale it up to something that might be the size of your house. So this is an area that has given me a lot of fun, both in my kitchen and in my office for a lot of years. I'm delighted to see you learning a little bit about it in your chemistry lessons. And I just encourage you to explore some of those lessons in the kitchen so that you too can walk away able to make the perfect cup of coffee. Thanks for joining us today. It's been a pleasure to talk with you.